Okay, this is lesson 19. We're on the home stretch of Module 7 and the entire 8th grade year. So in this lesson, we are going to focus on cones and spheres, you might have guessed. And the reason it's in this unit following the Pythagorean theorem is because the Pythagorean theorem is going to help us find some of the missing dimensions on these cones and spheres. So we're going to start with a couple exercises. Exercise 1 and 2, you can work out on your own. You need to remember the formulas for areas of circles and volume of prisms and cylinders. Everything else, I think, is given to you. No, you might need the volume for the cones. If you don't know that, go ahead and look it up. Go ahead and look back in your notes. I can't remember which module we did that in, but we did do it, and maybe you remember because we did a demonstration of it. So there's 1, and then 2 focuses on a prism, so you can find the volume of that prism, and then the pyramid that has the base the same size as the prism. Okay, so go ahead and pause the video and work on exercises 1 and 2. You're welcome to use a calculator if you need it. The numbers aren't terribly difficult though. Okay, so we are going to be determining the volume for each figure in these 2 exercises. So for the first one, they ask us to show the volume in terms of area of the base times the height. So the area of the base is capital B, and the base being this circle here. So the area of this base, which is the same as the other one's definition of a cylinder, times the height. So we just take the area of the base and multiply it by the height. Kind of makes sense because we'd just be, stacking a bunch of these up, right? Okay, so let's clean that figure up. Area of the base times the height. So the volume, then, first thing we need to do is put an expression in for the area of the base. And we have the radius. So the area of a circle is pi times the radius squared. So the area of the base would be pi times 6 squared. And at 6 inches squared, so that's 36 inches squared. And then this would be times the height. And the height here is this dimension right here, times 10 inches. So we've got times 10 inches. So now we can see that we've got inches squared times inches, which gives us volume. And then the rest of that will just straighten out. So we want to put those together. Inches squared times inches is inches cubed. So the volume is, let's do the 36 times the 10 to get 360 pi. And this would be inches cubed. Okay, so part B, write an expression that shows volume in terms of the area of the base and the height of the figure. Explain the meaning of the expression, and then use it to determine the volume of the figure. So notice that our area of the base is the same. It's a circle with a radius of 6 inches, and our height is the same because it's 10 inches. So this is a cone that would kind of fit right into that cylinder. So obviously its volume is less because we could draw the whole cylinder kind of around it right here. So its volume is less, and if you remember in class, most students guessed that it would be half the volume of that cylinder that it would fit directly in. But when we found out by pouring the rice into these different shapes, we found out that it was actually a third. So the volume is equal to 1/3 of the base, area of the base times the height. So notice that this expression here is the volume of that cylinder. So 1/3 of it gives me 1/3 of the cylinder that cone kind of nests in. Okay, so let's go ahead and determine what I'll be consistent here. See if we can figure this out. So we've got 1/3 times the area of the base, which is pi r squared. So it's pi times 6 inches squared, which is 36 inches squared. So that's the base. And then the height, once again, is right here. So the height, all this is the base, the height is 10 inches. Okay, so let's go ahead and straighten that out. So we've got our units are inches cubed. We've got 1/3 times, let's do 1/3 times 36, which is 12, times 10, which is 120. 120 pi, because we still have that factor of pi right here. 120 pi inches cubed. And they didn't tell us to use something for pi, so we're going to leave it in terms of pi. So it's 1/3 of that. Okay, so let's keep going here. All right, so now we have this prism. It's 12 by 12 on its base and it's 10 inches high. So the volume of a prism, now it says, let's read it though. Write an expression that shows volume in terms of the area of the base and the height of the figure. All right, so we know that we've got length times width times height on figures like this. But we can think of this as, remember, area of the base times the height, where the area of the base is actually length times width. You know, so we could say this is really length times width times height, because that is what the area of the base is 12 by 12 here in this case. So so it's just, if you're like me and don't have a good memory, then it's nice that these volume formulas really make sense. They really are what's happening. Because once again, just like the cylinder, if we stack up, you know, if we stack up all of these shapes the size of that base, squares in this case, we add them all up by multiplying by 10 and getting, you know, getting the height or getting the volume that way. So let's look at it. The area of the base is 12 inches times 12 inches. So that's the area of the base. And then the height is 10 inches. So our volume here, if we take out inches times inches times inches, our units are inches cubed. And 12 times 12 is 144, times 10 is 1,440 inches cubed. Okay. All right, now this pyramid and this prism are kind of like this cone and this cylinder. So let's look at it. Mathematicians consider a pyramid as a type of cone. So that's not the common definition of it. But let's look at it. We're not. Yeah, we are. Okay. The volume of the pyramid shown below is 480 inches cubed. What do you think the formula to find the volume of a pyramid is? Explain your reasoning. Okay, so this time they've given us the volume is 480. And we're asked to think about what the formula would be. So if you did these on your own, maybe you had a chance to think about it, we noticed that 120 is 1/3 of 360. So we might ask ourselves, is 480 right here, 480, so that's volume is equal to 480 inches cubed. Clearly this pyramid, which has a base of 12 by 12, just like our prism, and it has a height of 10, just like our prism. So we could ask ourselves, how many of these would fit in the prism with the same size base and the same height? Okay, well, let's guess 3. 3 times 480 is, that's 24, sorry. 3 times 8 is 24. 3 times 4 is 12, plus 2 is 14, 1,440. So 3 of these can fit in here, volume-wise. So we could say the volume is equal to 1/3 the volume of the prism, and the volume of the prism was just the area of the base, big B, times the height. You know, I might say volume of a pyramid is 1/3 the area of the base times, times, that didn't work, times the height. Okay, so pyramids have that same volume relationship with the prism that they fit in as the cone has with the cylinder that it fits in. It's that 1/3 thing. Okay, that's really handy because you don't have to remember so much. You can remember just a few things and it applies everywhere you go. Okay, so we're going to back up a little bit here. Okay, so I'd like to ask you to pause the video while you write as much as you can about a cone. Labeling the diagram would be a really good thing to do. And then just jotting down any formulas that you come to. Really just take a minute or two to do this. We're not looking for 30 facts about a cone, just some of the important facts. Okay, so go ahead and pause and do that. Okay, so with this cone here, we know that we have this perpendicular height. You know, this cone has a certain height that it goes up, and it has a circular base. You know, the area of, maybe you said the area of the base would be pi times the radius squared. You know, here is the radius. You could call this dimension the diameter, twice the radius. The circumference we could talk about, the circumference of the base is equal to 2 pi times the radius, or pi times the diameter. What else have we got? We know the volume is, 1/3 the area of the base, which is pi r squared times the height. Okay, so that kind of covers it. You might have a few other details that are on there. But what I want you to notice is that there is a dimension on this cone that we haven't addressed. And maybe you did in your, while you had the video paused. But the area that we haven't addressed is the length of, from the base up to the tip. The slant height is, so we call it, or the lateral length. So we're going to call it S because it's slanted. So this is the slanted part of the cone. Can be called lateral length. I've mostly heard it referred to as slant height. That doesn't look much like an S though. So we want this to be S. It's going to be bigger. The slant height is bigger than this perpendicular height, right? Because this is going to be the shortest distance from the base to the vertex of the cone. Slant height is going to be longer. Okay, so we might want to know what that dimension is on a cone. Okay, so let's look at some exercises, and I'm going to have you work on exercises 3 through 6 and then come back and check. But notice that now you're being asked to find the lateral length of the cone shown below. So that would be this dimension, which of course is going to be the same all the way along the cone. So they've given you a big hint here on how you're going to find this lateral length. And looks like you can use the Pythagorean theorem, right? So pause the video and look at exercises 3 through 10 and find whatever missing piece of information is needed. They will all ask for different things, it looks like. Okay, so on this first exercise, exercise 3, you're asked to find the lateral length. So that's this, S. And I'm going to use S for it. But S is the hypotenuse of this right triangle here. And the legs are the radius is one leg, and the height is the other leg. So I can say that S squared is equal to 3 squared plus 4 squared. You might not need to do this if you remember this special triangle, 9 plus 16. So S squared is 25, which means that S is 5. So the slant height here is 5 units because they didn't put any units on it. So 5 units for that. This is remember that famous triangle, 3, 4, 5 triangle. All right, determine the exact volume of the cone shown below. All right, so we have been given the height of the cone, but not the radius of the cone. And I'm going to need the radius of the cone in order to find the area of the base so that I can multiply by the height and multiply by 1/3 to find the volume of that cone. So let's first find the radius of the cone. So we're going to do that by using the Pythagorean theorem. So we'll call this R. Okay, so we know that R squared plus 6 squared is equal to 9 squared. So we get r squared plus 36 is equal to 81. And subtracting 36, we get r squared is equal to 45. So our radius is equal to the square root of 45. Okay, so we got that. So we found the radius. We know that's the square root of 45, so let's go ahead and put that in, that dimension. Square root 45. Notice I'm leaving it as a square root. The reason for that is because it'll just make it easier to use in the next section here. All right, so I'm going to try to fit the rest of this in here. We are asked to find the volume. So the volume for this cone is 1/3 the area of the base times the height. So that is 1/3 times the area of the base is going to be pi times the radius squared. Radius squared is right here. It's really all I needed. The radius squared is 45, so this is 45 pi, area of the base. And then the height is 6 times 6. All right, so now I can straighten this out. So the volume is equal to, so let's look at 1/3. 1/3 of 45 is 15. And then 15 times 6 is 90. Or I could do the 1/3 times 6, which is 2. 1/3 of 6 is 2. 2 times 45 is 90. Anyway, you do that, you get the volume is 90 pi. Volume of that cylinder is 90 pi. Or, sorry, cone. The volume of the cone is 90 pi. All right, so it was an extra step to find the radius, but we could easily do that using the Pythagorean theorem. All right, now let's look at 5. And again, hopefully you've tried this one already. 5, what is the lateral length or the slant height of the pyramid shown below? Give an exact square root answer and an approximate answer rounded to the tens place. All right, so here is the slant height. Whoops, that's not very neat. Right there. Perpendicular to that edge of the base. And notice that we've been given the height of this triangle. Been given the height here at 8 inches. My pen is just not being very accurate here. And another leg of that triangle goes to the center of the base there. So that's 4 inches. So we're asked to find the lateral length or the slant height. So I'm going to label it S. And we can use the Pythagorean theorem, right? Because S squared is equal to 8 inches squared plus 4 inches squared. So S squared is equal to 64 plus 16, which is 80. I can write it out. 64 plus 16, and this is inches squared. So our slant height squared is 80 inches squared. And I can take the square root of both sides and find that S square root of s squared is s, is equal to the square root of 80 times the square root of inches squared, which is just inches. 80 square root of 80 inches. So that's our exact square root answer. And now we want to round it to the tens place. So we know that the square root of 80 is going to be extremely close to 9, because 9 times 9 equals 81. So if I do either the rational approximation or use my calculator, I'm going to see that S is approximately 8.9 inches, 8 9/10 inches. Okay, so it's an inch longer than the height there. All right, so we found the slant height of that pyramid. We gave it as a exact square root and approximated with a decimal. All right, determine the volume of the pyramid shown below. So to find the volume of the pyramid, we need the height. So we can see that the height squared, because we've been given the slant height, plus 1 squared, so that's the two legs of our of this right triangle here, is going to equal this slant height squared. Okay, sometimes when you're using the Pythagorean theorem in 3 dimensions, it can get a little bit confusing, so just take your time. So the height squared, I'm going to subtract 1 from both sides, is equal to 2 squared, which is 4, minus 1, which is 3. So h squared is 3. H, or the height, is the square root of 3. Okay, so the height of our pyramid is the square root of 3, which we know the square root of 3 is between 1 and 2. So this height here is less than 2, greater than 1. Okay, so the height is the square root of 3. So what we want to do now is find the volume, though. So the volume of the pyramid is 1/3 the area of the base times the height. So we know what the height is, but what's the area of the base? Well, if it's 1 unit to get to the center, then this must be 2. And it's a pyramid, so that's square. So 2 times 2 is 4. The area of the base is 4 square units times the height, which is the square root of 3. Okay, so now we're going to write this all together. We'll write it as 1 fraction. So this would be, kind of times 4/1 times square root of 3/1. So we get the volume is equal to 4 times the square root of 3/3. And that would be cubic units. So let's get that on there. Units cubed. And of course those units are going to come in here, right? I didn't put them in, but this is 4 square units. This is square root of 3 units. So this would be units squared times units, which is units cubed. Okay, so 4 times the square root of 3 divided by 3. And that's what we get when we multiply those 3 separate products there. Okay, so we're going to switch our attention to circles here for a minute and then spheres. So we're going to say here we have a circle whose center is O, And we can have points on the circle, like so. We could call them P and Q. And we can draw a line between P and Q, and that's called the segment PQ is a chord of the circle. Call that a chord. And what I'm going to do now is I'm going to draw lines to points P and Q from the center of the circle. So these, of course, are the radius of the circle. We know that. And did it matter where I drew P and Q? I just picked out any 2 points. It doesn't, because when I draw those lines to the center, both of those will be R. Okay, so we've got this kind of isosceles triangle thing going on. Okay, so I encourage you to do that on your paper right now. If you have a compass, that's great to draw a circle. Otherwise, you can just freehand it. But place P and Q anywhere you want, and draw the lines draw OP and OQ, and see what different types of arrangements you can get. But you should find, of course, that the lengths OP and OQ are always going to be equal to the radius of the circle. Okay, now we've got a different picture to look at. Okay, but before we go there, let's just mention real quick that if this angle POQ, which is right here, that central angle here, POQ, if that angle is a right angle, then if we needed to solve for the length of the chord, we could. If we knew the radius, we could find the length of the chord by using the Pythagorean theorem. All right, so we're going to take this into 3 dimensions now. So here's our 3-dimensional figure here. So this is kind of the same thing we did with taking those, using the Pythagorean theorem on cones and pyramids. Now we're going to use it on a sphere. So on this sphere, we've got a point on the sphere P and another point on the sphere Q, and we have the center of the sphere, and we're saying that this is a right angle. So this segment PQ is still a chord. It's a chord of a sphere. And just like with circles, we could use the Pythagorean theorem to determine the length of that chord. Or if we knew the length of the chord, we could find the radius of the sphere. All right, so exercises 7 through 10 have some things you could do. You can use calculators, but show all your work, and unless otherwise told to do so, you can leave your answers as square root, in square root form. Okay, so go ahead and pause and work on 7 through 10. Okay, so for number 7, we're asked to find the length of the chord of the sphere, shown below. Give an exact answer using a square root. Okay, so both of these, this is a radius here. This is also a radius, so they're going to be the same dimension. So this is our missing length. Let's go ahead and call it C. Because we've got a 90-degree angle here, we can use the Pythagorean theorem. So we've got 11 squared plus 11 squared is equal to c squared. So this is 121. This is 121. So this sum is 242 is equal to c squared. And take the square root of both sides and get that c is equal to the square root of 242. Okay, so that is an exact answer using a square root, but I happen to know that that this has a square, this 242 can be simplified because I know that it's 11 times 11 times 2, because I took 11 squared and added it to 11 squared. Okay, so it factors to that. So this is equal to the square root of 11 squared times 2. So that's equal to the square root of 11 squared times the square root of 2. So this square root can be written more simply as 11 times the square root of 2, 11 square root of 2. So that is our dimension there. The chord length is 11 times the square root of 2, or the square root of 242. They're exactly the same thing. Might be fun for you to put this into your calculator. Do square root of 2 times 11, and then put in square root of 242, and you'll find that they're the same number. Okay, what is the length of the chord of the sphere shown below? Give an exact answer using a square root. Okay, once again, I'm just going to quickly show this. Okay, so I've just used the Pythagorean theorem here. 4 squared plus 4 squared is the length of the chord squared, c squared. So this becomes, I see that c is equal to the square root of 32 after I go through the steps. And going back to the lesson of simplifying square roots, 32 has a perfect square factor. It's 16 times 2. And so this is the square root. Square root of 16 times 2 is the same as the square root of 16 times the square root of 2. The square root of 16 is 4, and so this is 4 times the square root of 2. If you don't remember the simplifying square roots, you could go back and look at that lesson, simplifying square roots. All right, what is the volume of the sphere shown below? Give an exact answer using a square root. Okay, so volume of this sphere, and all we're given is the chord length. Okay, but to find the volume of a sphere, we're going to need its radius. Okay, so I've got a radius here and a radius there. So that gives us one variable, which is nice. So this is a right triangle here, so we can use it. So we've got radius squared plus the same radius squared is equal to 20 squared. All right, so r squared plus r squared is the same as 2 times r squared, and this is equal to 400. So r squared is equal to 200, dividing by 2 both sides. R squared equals 200, so, whoops, sorry. R squared is 200, so r is equal to the square root of 200. Okay, and I can rewrite 200 as 100 times 2, and I'm doing that because 100 is a perfect square. So this is 100 times 2. So this is equal to the square root of 100, which is 10, times the square root of 2, which is square root of 2. So the radius of this sphere is 10 times the square root of 2. All right, let's get a new page here. So the radius of the sphere we said was 10 times the square root of 2. All right, so what I want to do now is recall the formula for the volume of a sphere. And that formula is this. Volume is 4/3 pi r cubed. Okay, 4/3 pi r cubed. That's one you're just going to have to commit to memory here. So putting in our radius, we're going to have 4/3 times pi over 1 times the radius cubed. Okay, so this is 10 times the square root of 2 to the 3rd power. Okay, so we know when we have a product like that, two things multiplied together, we can take them each to the power separately. Because when we multiply this out, 10 times the square root of 2 times 10 times the square root of 2 times 10 times the square root of 2, I've got three factors of this and 3 factors of that. So this is going to be 4/3 pi times 10 cubed times the square root of 2 cubed. Okay, so we're just straightening out the numbers. So what I'm going to do next is I'm going to take this 10 cubed, which is 1,000, multiply it by the 4, and get 4,000 pi over 3. Okay, do you see where that came from? 1,000 times 4 divided by 3 still. So 4,000 pi times 3. And then we have times the square root of 2 times the square root of 2 times the square root of 2, right? That's what it means to be cubed. So we've got 2 here, so that becomes, those shrink down into 2, and then we still have square root of 2. So this square root of 2 times square root of 2 is 2. It's in the denominator of our fraction, so we've got 2 times 4,000 pi over 3. So this would be 8,000 pi over 3 times something. There was one little factor left here. These two became a 2 and multiplied the 4,000 here. So we get 8,000 pi over 3 times the square root of 2. And we can leave our answer like that, or we can notice that some people like to rearrange things. So we could have 8,000, and usually it's to get all of the number pieces together. 8,000 times the square root of 2 times pi over 3. And there's, your answer key writes the times pi like this. Just times pi. You could do that, or you could do it the way I had it just a minute ago. Okay, one last problem. What is the volume of the sphere shown? Give an exact answer using a square root. All right, so let's just go again. I'm going to go quickly because you've done these already, right? Okay, so r squared is 72. So r is equal to the square root of 72. And I'm noticing a perfect square factor in there, which is 36. So I can take and rewrite this as 36 times 2. And so our radius is 6 times the square root of 2. Now we need to find the volume of the sphere. So I'm going to get a blank page here. Our radius, once again, was 6 times the square root of 2. So formula for volume is V equals 4/3 pi times the radius cubed. So we're going to have 4/3 pi times 6 square root of 2 cubed. Okay, so we get 4/3 pi. 6 cubed is 216. So think of this as 216 over 1, multiplying by it. Square root of 2 cubed, square root of 2 times the square root of 2 times the square root of 2. That's the square root of 2 cubed. So remember, these kind of collapse down, and that's 2 times the square root of 2. Okay, so let's just go ahead and substitute that. We've got times 2 times the square root of 2. Okay, so now that I've got this expression and everything there, I'm going to start, everything's being multiplied, so I can take out factors of 1, top and bottom. So 2 over 2 is 1, and then I can rewrite 216 as, because 216 divided by 3 is 72. So I take a factor of 3 out of that, and I get 72 right here. And so now we can write that the volume of the sphere is equal to, I need to take 4 times 72 and pi, and then the square root of 2. So first, 4 times 72 is 280 plus 8 be 288. Okay, sorry, I'm just noticing that I made a mistake as we went along, so I'm not, I could back up, I'm not sure where I got that to, but it's not correct. So I don't have this, I still have a 2 here. So this 2 down here does not exist. Okay, so, but I can still cancel the 3 there. So, but now I've got 8 times 72, because I've got 4 times 2 times 72. So I'm going to do that and get 576. So I've got 576, and that takes care of the 4, the 72, and the 2. And so then I've still got pi times the square root of 2. So the volume is 576 pi times the square root of 2. Okay, it's a little bit involved, but not terrible. All right, so let's summarize these volume relationships. The volume for a right square pyramid, which we don't have a picture of here, is 1/3 the base times the height. And so remember that we related the pyramid to the cone and had the same basic volume formula. You just had to know the area of the base and the height. The lateral length of a cone is known as the slant height, and it's shown here on this cone. So we learned about slant height, or also lateral length. We saw that we could use the Pythagorean theorem if we had this right angle here. So if we had a right circular cone, we could find the slant height using the radius and the height of the cone. We talked about what a chord of a circle was, and we related that to the chord of a sphere. And we saw that if this central angle from the circle here, this angle POQ, is a right angle, then we can use the Pythagorean theorem to find the length of chords or the radius of the circle or the sphere, depending on what was missing. We also talked about volume of the sphere, which is 4/3 pi r cubed. Okay, good luck with these problems. This is giving you practice seeing the Pythagorean theorem in 3 dimensions, which it's often used in. So this is pretty useful lesson. Okay, we're almost there.